Hello, my name is Niraj Kushwaha, a PhD candidate at the Complexity Science Hub and the University of Vienna. My PhD focuses on armed conflicts. Armed conflicts shape nations' trajectories, disrupt economies, and affect millions of lives, making them a major focus in scientific literature. Despite decades of progress, key fundamental aspects remain unclear, especially in building quantitative models. One such question is, what exactly is the object of study we are trying to model? In other words, how do we quantify armed conflicts? At its core, conflicts are collections of individual conflict events. For example, a bomb blast at location 1, a fight at location B, and some other infighting at location C. While currently experts group these events using heuristics like administrative boundaries, involved actors, or country borders. While well informed, these methods are rigid and inherently subjective. Also, conflicts exist at multiple narrative scales. For instance, at a local level, these two events in Nigeria can be studied as part of the Boko Haram insurgency, while the conflict event in Mali can be studied as part of the war in Mali. But at a broader level, these three conflict events can be linked to the larger instability in the Sahel region. This highlights the lack of a clear quantitative definition of armed conflicts and a systematic way to navigate between these scales. In my research, I use statistical physics and information theory to bridge this knowledge gap. Using disaggregated data from Euclid, which provides fine-grained location and time information of individual conflict events, I developed a purely statistical three-step method to generate groups of related conflict events. Here, relatedness is measured using an information theoretic measure called transfer entropy. With this method, we can generate conflict event groups, related conflict event groups across Africa, offering a principled alternative to the heuristic definitions of armed conflicts. When analyzing the temporal and spatial dynamics of these event groups, we found that they resemble avalanches in nature. Not only that, they exhibit similar statistical properties to physical avalanches, such as emergence of scaling laws in properties such as fatalities, duration, etc. Therefore, we call these conflict groups conflict avalanches. To validate our findings, we compare these avalanches to well-documented conflicts like the Boko Haram insurgency, Al-Shabaab insurgency, and Sierra Leone civil war. We found that our methods successfully reproduce these conflicts by extracting useful statistical signals from data. Furthermore, our approach is scale flexible, meaning we can generate conflict avalanches at any spatio-temporal scale. Interestingly, we found a mesoscale where we see emergence of meaningful patterns of armed conflicts. You can think of this as, if you're looking at armed conflicts from a microscope, this is the resolution at which armed conflicts show interesting patterns and that they are worth studying. Another big question is, how many types of conflicts exist? Again, in the literature, one can find tons and tons of heuristic definitions that vary from expert to expert, and therefore we set out to find classifications of armed conflicts that are quantitative in nature and can be expressed in terms of measurable variables. For that, I collected many datasets across 6 variable categories and represented each conflict avalanche in terms of these variables. Then we applied an unsupervised clustering algorithm to these conflict vectors, and we found that there exist exactly 3 main archetypes of conflicts that are major unrest, local conflicts, and sporadic spillover conflicts. In conclusion, in this research, we find a lot of useful insights about armed conflicts. We got a quantitative definition of armed conflict and now also know how many quantifiable conflict types exist according to data. Each of these types requires separate theoretical treatment, and one cannot build one theory that fits all. That's something what people in literature do currently. We also found the most useful variables when classifying conflicts, and they are raw demography, infrastructure, economics, and geography in order. I also concluded in my research that although these variables can be used to classify conflicts and understand their mechanism of spread, they can't be used to build effective predictive models. To know more about these results in detail, please feel free to go through the 2 papers that have come out of my PhD so far. Thank you.